Hello to my favorite math class. I hope you are having a really good day today. We are here for the third of four of these advanced equations. I'm looking at this blue section of the wheel, variables on both sides. We've done two-step, we've done fractions, and now we're looking at the situation where we have variables on both sides of our equation and what we need to do when that happens. So let me go down to steps where I have tried to cram all those in there for you. This process has 9 steps, so this is getting a little bit longer, a little bit more difficult. The good news is we're almost to the end of these. So we have this one and one more to learn about, and then you will know all about equations. So I know this is tough, but think about how much you have learned to do these. You've come a long way. Especially those of you who didn't know anything about algebra, you have really picked up some skills at this point. So once we learn all those skills, we'll be able to apply them to word problems. And that's ultimately where we're heading with this. So let me do just a little bit of editing here and get this out of the picture. And we'll take a look at these. Let me just go ahead and start reading them as I work here. Number 1 is to draw the power t. We know that. And you can guess what number 2 is. Almost. This is where the difference comes in. So I actually won't read all these. Let me just go ahead and show you how this works. So while I'm whiting out, because that mentions a boss variable, and I haven't told you about that yet. It's nothing to worry about. You can do it. We just need to take a look at it. So the example that I'm doing is negative 3x plus 6 equals 5x minus 10. So you probably already see the issue. But let's go ahead and draw the power t. Just like we always have. And at this point, we would try to decide which side is the variable side. And the thing about this is that there are variables on both sides. Fortunately, it's the same variable. It's the letter x, and that's a good thing. If it weren't a letter x on both sides, we would have a completely different situation. But we do have the negative 3x and we have the 5x. So we're going to have to make a decision here about which side we call the variable side. And this is how I recommend that you do it. You can do either side as the variable. But I tell students to look at the numbers, the 5 and the 3. And I'm ignoring the negative sign for the moment. We're looking at the absolute value of the numbers, 5 and 3. And ask myself which of those is larger. It's obviously the 5. So the 5 is going to be what I call the boss variable. So we're going to move all the variables to this side. I'll tell you just briefly why I do this, because you absolutely, instead of moving the 3, you could move the 5x. That's fine. But usually, if you find your boss variable, you will eliminate some negatives. And that's what I was always trying to do in school. It also gives you a pattern. It gives you a process to fall back on. So I'm going to move my variables to the right, and then that means that all my constants will line up on the left. And I'm going to go ahead, since I have this highlighted, and move the 3x. It is a minus 3x, so we're going to add 3x. Remember, if you're moving something, you always do that with opposites, with inverses. So I'm going to bring it over here and cancel this out, and then copy. So I have positive 6. Then we have a total of 8 x's and a minus 10. And do you see how I have eliminated that negative 3, which is a good thing to me because I don't like negatives. Okay, ask yourself what needs to move. Well, we need to get this negative 10 over here with the constants. So we're going to move that with its opposite, which is a plus 10. Cancel and copy. So 8x on one side, 16 on the other. And ask yourself what needs to move. The coefficient needs to divide away. So we will divide both sides by 8. And I'm left with x and 2. And clearly that is not standardized. Let me move it up just a little bit. I'm running out of room here. We have an x and a 2 when we copy, so we want to standardize that solution. You will see when we get to inequalities why I want you to standardize. So that very long equation comes down to x equals 2. Okay, let's look at another example up here at your turn. Here's this one. And let me take my white pen and highlight, cover up this curved equation and put in the one I need. Negative x minus a 9 equals negative 7x plus 21. So the first step, of course, is to draw the power t. We want to separate the sides. I'm going to put a 1 in front of that x just so you can see it sitting there. And I need to decide which side is the variable side. The 1 and the 7. Of those two, this side is the boss. So I'm going to line up my variables over here on this side. And that means that my constants will be on this side. Now this one has a lot of negatives and minus signs, so I need to be very, very careful. I'm going to move the plus 1x over here and cancel it off this side. Be careful when you copy because you don't want to lose that minus 9. It's a negative 9 sitting there. The negative 7 plus 1 leaves me with negative 6x, and copy the 21. And ask yourself, of the negative 9, the negative 6x, and the plus 21, what needs to move? What's on the wrong team? It's this one. So I will minus 21 on both sides, cancel where I can, and copy. Negative 9, negative 21, that's a total of negative 30. And then ask yourself, of the negative 30, the negative 6, and the x, what's on the wrong team? The negative 6. The coefficient needs to divide away. Take the negative sign with it. So negative 6 into negative 30 is positive 5. And then the last step is to standardize. So x is 5. That is not an easy equation. When you think about where we started with equations, this is not a baby step. This is a major step. It is a 3-step equation with negatives, and that is not easy to do. So if you are even remotely following what I'm doing here, be proud of yourself. That's a very, very big accomplishment, and I'm proud of you. That's great.